run the Kickstarter for? I know you can't do it forever, right? Is there like a certain minimum time frame you have to cut it off if you don't meet your goals yet?
So it's 1 to 60 days.
Okay, that's pretty fast.
I think we're going to do it about 35 days, or I got to check that because it ends on it ends specifically on a Thursday, and so we can. The reason that we find that important is if we want, we can do a end of campaign event. So maybe to get a few more contributions at the end, or just to leave it on a good finishing note.
And so you said you're trying to raise 30,000, right? So what happens if you only raise 10,000? You keep the 10,000, or you don't keep it because you didn't raise the full amount?
If we raise any less than 30,000, we won't be able to keep any of it.
Okay, man, that kind of sucks.
Well, we can always either find another source of funding or try again.
Yeah, that's true. So here's one thing I think a lot of founders have trouble with, right? Of course, you got to work in the day-to-day, right? You got to get part of market fit, all this kind of stuff, right? But you still have to figure out what if like it does work, right? Like I think I saw you story on LinkedIn where David, what would Charles say? I need 40, right? You said I don't have 40, right? So what happens if you do this and then you get an order for 10,000 or 1,000, right? I mean, that's a good problem to have, right? But how do you balance like focus on what you need to focus on now, like keep still planning for the future success?
So if we suddenly get an order that's too big for us to fulfill, I mean, if we need to say no, we have to say no. I mean, it's a great problem. It's a great problem to have, and I probably have to apologize to whoever believes in us that much at that point. But a healthy company grows organically.
And so I'm going to do a demo of a robot in a minute, but these robots you're making, where are you actually making them at?
So I actually made this one at home. This is still a demo. This is not the final product. So you can see by all the mess of wires in the breadboard here that it isn't as plug and play as I would like the final product to be.
So have you thought out, like, if you do get like 10,000 orders, right? You'd have to like go to some kind of factory in China, Vietnam to make it. Like, how would all these things be made if you did get a mass order?
So we're still kind of optimizing that. We're going to start with factories in state, or in state as we figure it out, and as time goes on, kind of start looking into different factories and manufacturers so we can kind of optimize a price. And working with different factories around the world, there are different concerns from local culture, language barriers to even concerns with IP. So,
what does this thing made out of, right? Is it plastic, metal? Like, can you talk about what it's made out of and why it's made out of that material versus something else?
So the plastic here.
Raise it up a little bit.
Sorry.
Yeah, like that.
Plastic here. It's PLA. So one, it's the 3D printer filament that I happened to have when I was designing this. But it's also, but I like it because it gets the job done, but two, it's a bioplastic, so it will disintegrate in the environment. So it is compostable. So I want to do as much as I can to lower any environmental impact that my company has. The things I can't control, though, are these electronic components. So these servo motors, let's say, they're made of a plastic that I don't have any control over. I might not be able to control everything, but I will do as much as I can to make sure that my part of it is at least environmentally friendly.
So, what makes something a robot, right? What's the definition of a robot?
I think it's. I guess this would strictly not be a robot by the definition that I have in mind, which is a machine that does the work of a human. Mm-hmm. I guess this is more of an animatronic, or it's a machine that kind of moves like an animal.
Okay. And how long does it take to build one of these things?
Are you talking about design or put the kit together?
Let's do both.
So, uh, I think the design, if I was the 3D modeling and printing, it'll probably if I rushed it, I could probably create something like this in a day and a half. Not the Where it kind of gets difficult is the electronics themselves. Uh, so. This demo today, it's unfortunately I'm unable to get it to move because I need an external power supply that can feed into it a stable 5 volts. So the next thing I'm working on right now is designing a circuit called a battery management unit. So these robots will be using rechargeable lithium polymer batteries. But the problem with lithium polymer batteries is they're very temperamental. So the specs that we want to meet is to create something that charges from the 5 volts that you can get out of your laptop, so using USB, and it can run this robot for a meaningful enough amount of time, and at the 5 volts required to move these motors. So a cheap lithium polymer battery is at 3.7 volts. So I need to create a circuit that charges it as well as boosts the voltage up to 5 volts. And the problem with lithium polymer batteries is if you charge them the wrong way, they explode. If you overcharge them, they explode. If you draw too much current all at once, they explode. If you discharge too much power or too much of the energy, they explode. So a battery management unit is extremely important for safety and as well as practicality.
So you making this company, so you want to help young kids like make robots, right? Why do you think that's important for them to know how to do this?
So it's so I guess or one disclaimer. Disclaimer real quick. This robot will be rated ages 13 plus. So for any younger students to use it, they will need to use it with the teacher or parental supervision. So the reason I think this particular kit is important is I guess the differentiator that I wanted to put into a robotics kit over let's say a kit like Mindstorms is the tech skills that you walk away from the kit with are real and transferable. And what I mean by this is I took a robotics class when I was in middle school, and it was Mindstorms and Lego Mindstorms. And Lego Mindstorms are great because you can use Legos to design the structure of a robot. You can program it using blocks on the screen that you drag and drop, and like all the electronics are easy. You just plug and play. So they create good classes for teaching students how to problem solve and to work together. But at the end of the class, even though I had fun, I was angry at myself because I didn't know how to do anything. I didn't know anything about electronics, and I still didn't know how to program. So it was a couple years later where that I had to kind of learn about electronics and these microcontrollers to start building my own robots. So I started building Arduino bots in high school, and the friction I kind of want to solve is that I had to spend hours and hours and hours teaching myself. With this kit, I want to make it so that students will have a streamlined experience when learning electronics, when learning programming, when learning about microcontrollers. So because those skills are transferable, those skills are important.
And so it's planned to have all these kids learn all these skills directly from your company. Are you gonna sell the stuff to like the schools and stuff? How's that gonna work?
I think we'll have some videos online and a book that we do publish with this or publish along with the kit at some point. But we will be working with third-party organizations to get these kits out there. So I'm not sure if it was mentioned during the course of this interview, but we are working with David Robichaux's company Black Muse, and they have a contract with schools and after-school programs in 4 different states. They want to get these kits into the classroom, and we are creating a curriculum to go with the kit that they will be disseminating on our behalf.
So what kind of transferable skills do you think do you know the kids can gain from doing this?
So the transferable skills, so of course the soft skills, same as mine in terms of teamwork and problem solving, so getting the robot to do different tasks. But the transferable tech skills will be so basic electronics, programming, programming in C, and how to use microcontrollers. And the biggest value about that is, or the biggest value when it comes to these skills is, this kit actually does not have to be a robot.